In this lesson, we're still going to be dealing with exponential expressions, but the new scenario is that we're going to be raising a power to a power. What in the world does that mean? It means that you're going to be looking at a situation where we have exponents inside of a parentheses and exponents on the outside of the parentheses. Now, just so that way you know how to read this, you could actually pronounce it like this: 2x to the fourth power, just like you always have. But then you say, when you see the end of the parentheses, you say raised to, and then you name whatever power is on the outside. So 2x to the fourth power raised to the third power. Don't ask me where it came from. It's just accepted. This is what I need you to understand, that when I say 2x to the fourth power raised to the third power, you're talking about something that's inside of parentheses. Now, first off, we're going to talk about the shortcut of how we can actually get through this to simplify it and get rid of all these extra exponents. And then we're going to take a little bit of time to see why it works. And then hopefully it will help you understand what's going on. Distribute the outside exponent. And the distributive property deals with multiplication. So we're going to take this 3 right here, and we're going to multiply every single exponent available. So this x has an exponent of 4, and 3 times 4 is 12. So we will make that x to the 12th power. Now, it was not in the notes of lesson 5, but we definitely covered it in class. We said that if you ever see a variable like x sitting here, and then it was multiplying x to the third power, we know that really this first x has an exponent of 1. So if you don't see an exponent, there is an exponent of 1 just sitting there. And that allows us to be able to say, hey, this is x to the fourth power. The problem with this lesson is that people are in such a rush that they forget that every single number has an exponent if you don't see one. This has an exponent of 1. So we take this 3 and we multiply all the exponents inside the parentheses, even the ones we don't see. 3 times 1 is 3, so that's the exponent for the 2. And then just make sure your coefficient is finished. Well, this is our coefficient. It's a number multiplying the variable, but it's got its own exponent. So 2 to the third power literally means 2 times 2 times 2, which is 8. So this becomes 8, and x to the 12th we just leave sit because we don't know what x is. So all of this gets worked out to be 8x to the 12th power. Now, why on earth does this equal 8x to the 12th power? Why does this work? Well, to be honest, it's similar to lesson 5, but it takes time to do it, so we usually skip it and use the shortcut that we used above. But all of this in the red box, basically what's inside of the parentheses, is really happening 3 times, and it's multiplying each other. So let me write that out. 2x to the fourth times 2x to the fourth times 2x to the fourth. So you see this happened 3 times, 1, 2, 3, and they're multiplying each other. And we've taught you what to do when you run into a algebraic expression that you're trying to simplify, when basically they're just multiplying each other. You would multiply your coefficients. So let's get green here. This is a coefficient, this is a coefficient, and this is a coefficient. 2 times 2 is 4, and 4 times 2 is 8. And then we also said that you would be able to take a look at your variables or anything that had exponents. And if the bases are the same, so let's go through and look at the bases. Base, base, and base. All of our bases are the same. In this case, they're all x. Then you'd be able to add up your exponents. 4 plus 4 is 8, and 8 plus 4 is 12. So you see, we still get 8x to the 12th power. But it's a lot easier if you go, you know what? Take the outside exponent and multiply it by all of the inside exponents. So here's a 1 for this 2 since it doesn't have an exponent. 1 times 3 is 3. So the new exponent for the 2 is a 3. And 3 times 4 is 12, so the new exponent for the x is 12. Once you figure out that 2 times 2 times 2 is 8, you're done. And you'll get quicker using this method. You'll probably be able to skip all of this and go straight to this in your head, unless the numbers are just really complicated. But it's a lot quicker and more efficient than doing it down here. But this is why it does work.